A bed of particle is projected from a point O with an initial speed of 60 meters per second. It strikes the ground at a horizontal distance of 300 meters from O. Take G as 9.8 meters per second square. We ask to find A, the angle of projection, B, time to reach the maximum height, and C, total time of flight. So solution. Let's represent this question with a diagram. So it's going to be just a rough sketch. So this is the projection, and then this is the velocity of projection, initial velocity u. So this is the range from this point O to this point. So in the question it is given as 300. So see it again, it strikes the ground at a horizontal distance of 300 meters away from O. So from this O to this point, we're going to take it as 300 meters. Alright, so this is the angle of projection, which we asked to find in A, the angle of projection. So let's write out the parameters we have. So the initial velocity u from the question is equals to 60 meters per second. The acceleration due to gravity g is given as 9.8 meters per second. So we have the range, which is r is equals to 300 meters. So asked to find the time of flight. I will represent it with a small letter t. Then the total time of flight, which I will represent with capital letter T. And then which other one again? And then projection angle. Let me just represent it with theta. Now we are going to start with the projection angle since we already have the range. So the formula for range is r is equals to u square sine 2 theta divided by g. In this equation we have u, we have r, we have g. The only thing we don't have is theta. So let's make 2 theta the subject of the formula here. Let's multiply both sides by g. So this g and this g will cancel. We left with gr is equals to u square sine 2 theta. Let's divide both sides by u square. We're going to have sine 2 theta is equals to gr divided by u square. So we're going to have that 2 theta is equals to sine inverse of gr divided by u square. So let's divide both sides by 2. So this and this will cancel, and then the final equation for the theta is equals to sine inverse of gr divided by u square all over 2. So I'm going to plug in the value of g, u, and r into this equation to find the value of theta. So you have that theta is equals to sine inverse of g is 9.8 multiplied by r, which is 300, then divided by u square, which is the u 60 square, this. Square, and all of this will be divided by 2. So you're going to have that theta is equals to, just plug this in your calculator the way it is, then you get the value of theta. So we're going to have sine inverse of 9.8 multiplied by 300 divided by 60 square, then everything divided by 2. So we're going to get that theta is equals to 27.36 degrees. So this is the value of our theta. Let me just put it this way. So theta is 27.3 degrees. So B is time to reach the maximum height. Now the time to reach the maximum height is given by U sine theta divided by G. So T is equals to U is 60 multiplied by sine theta here is 27.36, then this divided by 9.8. Just input this in your calculator the way it is. So we have 60 multiplied by sine 27.36 divided by 9.8. So we have that T is equals to 2.81 seconds. By the way, the time to reach the maximum height is the time it will take this body to travel from this point of projection to this point. So this point is the maximum height of this projection, right? Now the question number C, total time of flight, is just the time it took this projectile to travel from this point to this point. So you can see that the total time of flight is the time it takes this object to travel from this point to this maximum height, and then from this maximum height to this ground level, alright, which is just this and this, right? This and this are the same, so it's going to be 2 times the time to reach the maximum height. So with this, we are going to find our total time of flight as 2 multiplied by time to reach the maximum height, which is equals to 2 multiplied by 2.81. So this is going to give us 2 times 2.81 is equals to 5.62 seconds. So this is equals to 5.62 seconds. Thank you for watching. Don't forget to subscribe to my YouTube channel, like this video and share with your friends. Have a nice day.